Lesson 108. This is your mini lecture. This one's about matrices. Adding, super easy, you just add the elements. Multiplication, not as easy. If you were in my Algebra 2 class last year, I think we did some of it. So these are different ways that different textbooks show matrices. This is a 2 by 2, 2 by 4. So it goes, the first number, it stands for how many rows, and rows are like counting horizontally. And then the second number is the columns. Okay, and I had a student who said they can remember that because they say race car. Rows, columns. So rows are going to be 2 rows, 4 columns. Okay, so that's important. That's called the order of the matrix, if it's a 2 by 2 or a 2 by 4 or whatever. What else do you need to know? You need to know, oh, the little things inside are called the entries or the elements. I think I call them elements. What else do you need to know? So when you're adding two matrices, you just add the elements that, the corresponding elements. You need to know that addition is commutative. Like, you would always expect addition to be commutative in the real number system, and it is also with matrices. And we know subtraction is not commutative even in the real number system, so we wouldn't even think to try that. But the thing that's tricky about matrices is in the real number system that you've grown up with since you're little kids, you have always known that like 3 times 6 is the same as 6 times 3. You know what I mean? Like, it's the order doesn't matter when you multiply. Well, that is true in the real number system, but that is not true with matrices. So B times A might give me a totally different matrix than A times B. And actually they usually do. There's a matrix called an identity matrix. So this one would be an additive identity right here, because if you add 0 to anything. So that makes sense, just like it would in the real number system. There's also a matrix, the multiplicative identity matrix, and it looks like this. It's always got 1s and 0s in it, and I'm not sure that we're going to talk about, like, so if it was a 2 by 2, that would be, if I multiplied any matrix by this matrix, you always start out with a 1 in the left-hand corner and then make them go diagonal. If you multiply anything by this, it won't change the thing that you're multiplying. You could even have one that's 3 by 3. It would just have a 1. It'd have like diagonals, and then the rest of them would be zeros, like that, I think. There we go. Okay, so those are identity matrices. In other words, you can multiply those by something and not change the thing that you're multiplying. Not sure if they're going to tell you about that. I'm going to show you when you can and can't multiply matrices. There's something about their order that you have to know. I'm just trying to stress really hard that matrix multiplication is not commutative. So A times B does not equal B times A. Okay? It doesn't. When we multiply, you can read all this. Here's the identity matrices. See, they showed them all out. They always have like 1s going diagonally from top left to bottom right. Okay. When you multiply these, you can read it the way that they write it, but I'm going to show you, how I do it when we do our example. I'm going to go ahead and do an example now. So this is pretty easy. It says I'm on number 6, and it just gave me these two matrices, A and B, and it just wants me to add and subtract. So when you add matrices, all you do is add the little elements. So you take, row 1, column 1. I got my finger on both of them, and I'm going to add them together. So that should give me -1, right? Adding them together. And then I think I'll go across the top. 0 plus 1, well, that's 1. Alright, and then the 1 plus 0, well, that's still 1. 0 plus 3, that's 3. 2 and 2 is 4. 3 and 0 is 3. 1 and 4 is 5. 1 and 4, well, that's 5, and 0 and 0, 0. So get it? We're just adding up the elements. I'm checking that. That's why I'm being quiet. Checking it to make sure I didn't. Sometimes I do bad arithmetic. Okay, now we're going to subtract. So a minus b, so it's 1 minus -2. If you minus a -2, that's 1 minus -2. That's going to be 3. 0 minus 1. 1 minus 0. 0 minus 3. 2 minus 2. 3 minus 0. Does this make any sense? 1 minus 4. 1 minus 4. 0 minus 0. Get it? Easiest thing in the world. 2 times a, that's called scalar multiplication. Just multiply everything inside a by 2. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. 2 times 0 is 0. 2 times 2 is 4. 2 times 3 is 6. 2 times 1 is 2. 2 times 1 is 2. Hopefully I don't mess this up. 2 times 0 is 0. See what we did? We just scaled it up by 2. We doubled. Basically, we took this one on the top and we doubled it and got that. Okay, that's how you do that. Now I want to do I have time on this video? Yeah, probably. Okay, so I'm supposed to multiply a times b and then multiply b times a. We're going to show you that they're not going to be the same thing. And actually, you're only allowed to multiply them under certain conditions. So what is the order of this one? Or what size matrix is it? It's how many rows? 3. How many columns? 1. It's a 3 by 1, okay? This thing, how many rows? 2. How many columns? 3. If these two don't match, then you cannot multiply them. So guess what? A times b, not going to happen. You have to have the column in your first matrix has to match the row in your second. So we're going to say not possible. But if I switch them around, b is a 2 by 3 and a is a 3 by 1. See that? If I switch them around, now this matches. So that means I can multiply and my answer is going to be a 2 by 1. So b times a is going to be a 2, it's going to be a 2 by 1 matrix. So b is, I think I'm going to probably have to do a 2-part on this. I'm going to set this thing up and then I'll actually multiply them out in the next video, because if I hurry through it you might get confused. I'm just setting it up. There's b, and then a is this one. 1, 1, 1, and we said that the matrix it yields is going to have row, column. 2 rows, 1 column. It's going to be a 2 by 1. 2 rows, 1 column. So I think it's just going to have 2 numbers. Now I'm going to I'm going to have part 2 to show you how to multiply them together. So tune in for part 2.